Every container has its own isolated file system. From a containerized process's perspective, there's nothing special about this file system. However, any data that's saved onto the container is tied to the lifetime of that container. If a container crashes or is otherwise terminated, all data saved in the container layer will disappear forever. Even when a container crashes and gets recreated, the data saved onto the old container will not show up on the file system of the replacement. The new container starts off with a new file system only containing the files from the image which created the container. Some situations call for a storage location which is independent of the lifecycle of any particular container. For example, let's say that you want to run a database, such as MySQL. You'd certainly want the database to store its data in a location which would survive container crashes and pod evictions. This is why Kubernetes has volumes.
A volume is a special type of storage location. What makes volumes special is the fact that they have a lifecycle which is independent of any one container. From the perspective of a container, a volume is just a directory. What this means is that a volume is mounted as a directory onto the file system of a container. Therefore, when a containerized process saves data in the mount directory, that data is stored in the volume and not in the container. There are two reasons why you'd want to use a volume. The first reason is to save data in a durable location. The second reason is that a group of containers can use a volume to share data. These are just a few of the things that we're going to learn about in this chapter. While there are many different types of Kubernetes volumes, they all have a similar structure or format. Therefore, let's look at an example of how you would declare a volume for a pod and how you would then mount that volume onto the file system of one of the pod's containers. What you're looking at is the config file for a pod called single-vol example. Note that this is not a valid pod that Kubernetes can create. It's just meant to show you the generic syntax for using volumes. Down at the bottom is the volume section. It defines a list of volumes which you can mount onto the pod's containers. It's kind of like a list of variable declarations, but instead of declaring variables, we're declaring volumes. Each volume has a name and a type. The name can be whatever you want it to be so long as it's a valid DNS label and is unique within the list. Basically, it can be made up of ASCII letters, digits, and hyphens, so long as it doesn't start or end with a hyphen. There are many different volume types. Here's a fairly complete list of what's available. There are volumes which are backed by various cloud providers, and there are volumes for many of the best-known network file systems. And there are volumes that are backed directly by cluster nodes. If you want it, then there's a good chance Kubernetes supports it. Each container can define an optional volume mounts field. This is how you mount volumes onto the container file system. To do so, you need to specify the name of one of the volumes in the volumes list. You then need to specify the mount path in the container. It just needs to be a valid path. But it cannot be a path to another volume. Volumes can never mount onto other volumes. Volumes always mount onto containers. That's the gist of how you set up a volume in a pod. Now let's look at a second example of a pod which has multiple volumes and multiple containers. This pod has two containers, imaginatively named C1 and C2. It also has two volumes, named V1 and V2. Container C1 defines a mount point for both V1 and V2, whereas C2 only defines a mount point for V2. What I'm trying to demonstrate is that each container can mount any number of volumes.